Hello everyone, my name is Mikhail Levchenko and I'm a PhD student in the Institute of Optical Materials and Technologies, and also I'm a PhD student in Technical University of Berlin. So today in this short video I'm gonna briefly describe you a topic of my research project, which is called Analysis and Compression of Dynamic Speckle, and also I'll describe you what a dynamic speckle at all, what problems do we face when we use these methods, and I'm gonna tell about what I'm working on in my project to improve this method. So let's go! Dynamic speckle is applied in different fields, such as controlling of blood flow in human vessels, non-destructive testing of different objects, bacterial testings, and there are many other applications. Before talking about dynamic speckle, we have to understand what is speckle at all. As we know, the surface of every object is rough. If one illuminates the surface with a coherent light source, such as laser for example, the interference phenomenon is obtained and as a result speckle patterns are formed. Shape and brightness of patterns of this depends on surface condition. Here is shown the speckle pattern image. Speckle image is captured with camera. And if we capture the sequence of speckle images and then analyze them with dynamic speckle methods, at the end we would be able to obtain activity map that shows us the activity distribution of activity that is ongoing within the object. And as a result, these activity maps can help us to understand, for example, how fast blood flows within the human vessels, or we can find different cracks on objects while we're using these dynamic speckle methods in non-destructive testing. Here you can see the scheme of acquiring data in dynamic speckle. To build one activity map, you have to use the sequence of speckle images. And the longer controlled object is observed, the more speckle images have to be captured. And now let's imagine that we're making the experiment for 1 hour and 20 minutes with a delay between every frame for 80 milliseconds. So how much disk space will we need to store the whole data of these images? In this experiment, we capture images with resolution 640 by 480 pixels in the format TIFF. And the number of images is equal to 60,160. So the size of all images is 126 GB. And this is the first problem that we face in dynamic speckle methods. We have to store all this data on the disk because we can use different methods to get better quality of obtained activity maps. In addition, methods that are used to analyze dynamic speckle images are noisy by themselves. So, to sum up, the main nowadays problems in dynamic speckle are: first, captured images need a lot of disk space and it can't be compressed with lossy standards. Second, algorithms implied in dynamic speckle are noisy. And third, I believe that there are more fields where dynamic speckle methods can be implemented. There are three main goals in my research project. First, I want to apply the most appropriate data compression algorithm. Then I want to improve or develop algorithm used in dynamic speckle to minimize and reduce the noise while building the activity maps. And the last goal is to explore new fields where I can use dynamic speckle. That's all what I wanted to tell you about my project. Hope you enjoyed this video. Bye!